Hi everyone, in this video we are going to unlock the power of AI motion capture with Unreal Engine and Autodesk Flow Studio. Craft your own stunning cinematic animations effortlessly even if you're a complete beginner. You can create this with just your smartphone and without any expensive gear or mocap suit. And in this video, here's how we did it. By implementing this system in our pipeline, we were able to produce these results. Many studios are embracing AI tools to significantly enhance productivity, including motion capture and animation prompts. With the right tools, we can combine it with newer methods to have quicker results. While larger studios have advanced tracksuits and equipment, smaller studios face significant challenges in acquiring resources. Hi, I'm Jacqueline Vicente, and I'm here to share our experience with AI motion capture powered by Autodesk Flow Studio paired with Unreal Engine. This innovative approach can elevate your projects and streamline your workflow. So don't miss out on the potential that AI can unlock on your projects. I know how challenging it could be to come up with unique animations. There's a lot of research and development that takes place before coming up with great movements. Our studio focuses on coding and simple asset creation, so you see the picture. This studio considered hiring professional motion capture services to help out with the animation, but was financially exhausting, and investing in $1,000 mocap suit that will only be used on rare occasions seems inadvisable, especially since we're not an animation studio. Purchasing animation packs was not the best of interest and it's too gamified for our needs. We needed unique and realistic body gestures with signature moves that will be used by our 3D characters with a quick turnaround pace. We were exploring new approaches, so I created a system wherein we can produce our own unique animation library using mocap and at the same time enjoy and learn the process of making it. AI motion capture technology is progressively entering workflows. We utilize Autodesk Flow Studio, formerly known as Wonder Studio, and with our years of experience in the game industry and have experimented with different workflows, it was pretty quick to learn and integrate this to our pipeline. The Flow Studio's interface is pretty straightforward and adequate enough for motion capture. You just need a camera to capture your video reference, a good location with clean background in the horizon, and your actor. You can even use your phone camera, or if you have a professional camera. What matters most is capturing clean, stable footage with clear movement, because that directly affects the quality of the motion data. Now that we've captured everything, it's time to use Autodesk Flow Studio and begin converting our videos to mocap data. Okay, now we're inside Autodesk Flow Studio. We can access this through a web browser. Go to your Autodesk account and then type Flow Studio, and then this one will show up. So right now we are using a free plan version for Flow Studio, and there's a lot of options that we could choose from, and there is also a paid tier. So now we'll be creating, and we're going to choose live action easy. So this is the scene or the viewport. Now we're going to import a video that we're going to convert. We have 15 seconds left for the free plan, and we're going to use a 15-second video. Now let's drag this to the timeline so that the software can analyze the scene for us. Now let's press next and then select scan frame for actors. So this means that the application is asking us who is going to be the actor that is going to be scanned for this shot. So right now we're going to scan Miles, our actor, and then we're going to assign a 3D actor for Miles. And we're going to select the dummy robot. So let's just drag that over the actor, and then the application will analyze this. So now inside this window, let's just enable everything that is available for the free plan. So right now we have USD and UE. These are only available for paid plans, but since we're using a free, these are not available. Then let's start processing, and then let's wait. So this could take a while, could be a few minutes to 1 hour. It really depends on your internet speed, but we're going to speed this up so that we could save more time. Okay, so now it's converted. Let's now check the file and see what it looks like. So double click All right, so it converted our actor Miles into this AI robot. It's doing pretty well in mimicking the movement of our actor. So we've created our first motion capture video, and now we're going to export the scene. So there's a lot of option here, from export video to export scenes. Got AI mocap, camera track, template, and export texture. Let's try exporting everything since we're using a free version, and let's make the most out of it. Okay, we're going to transfer and check this out inside Autodesk Maya. So just a recap on Autodesk Flow usage. Autodesk Flow Studio captures big body movement and facial tracking. However, it does not capture small joint movement of fingers elegantly from a far distance. The translation of movements get distorted, so it's better to leave it out. Manual Fix is the only solution for this. They also offer 300 credits for their free version. I was so excited to convert all our video recordings that I did not thought about the credits consumed. So if you exhaust all the credits, you have to wait 30 days for it to replenish. On our end, we were compelled to buy a plan with more credits, which only costs us around $95 for 1 month. You actually save a lot since you can do the shoot without any tracker suits. It's intelligent enough to track movements, and if you're an independent filmmaker or game developer trying to create new animation movement, I highly recommend this. Now let's jump into Autodesk Maya to prepare and clean our file. Now we're inside Autodesk Maya, and we have imported our AI mocap file in the scene. Let's start cleaning our scene and deleting this camera because we won't be needing it. Now, let's adjust the joint's odd proportion. We can fix this by changing the joint radius from 0.77 to 0.025 so that it won't look crowded on the screen and all will share the same joint size display. Now, let's move to the spine. Obviously, it looks crooked. We're going to fix this as well, but first let's check what the animation looks like. Okay, looking good. Let's start fixing this by moving our biped into the center grid. But we can't do that right now because of the frame-by-frame set key animation present in our timeline. For a solution, we just need to create an animation layer so that it can record and recognize a new animation or movement on top of the pre-existing one. So let's go to the animation layer located at the lower corner of our screen, and then inside, select the plus button. Let's make sure that all joints are selected before pressing the plus button so that all joints will be included in the anim layer. Now let's create a new set key, select the hip joint, and move it to the center grid. Make sure that the feet are touching the ground, and just do a little bit of tweak. Now let's proceed to the spine, do some adjustments, and don't forget the set key. Now that's fixed. So let's do some double checking for extra frames. Let's remove the T-pose by deleting the extra set key on the timeline. Now let's create another layer to organize and prepare our scene, because we will be importing another joint system. It's going to be UE Manning since we are working on Unreal project. You might be wondering, why not just import it directly to Unreal Engine? Based on our experience, when we imported the AI mocap directly to Unreal Engine, it did not read the files. So we did it this way. This worked for us. So as a workaround, we brought UE Manning into Maya together with AI mocap to transfer the animation properly and then brought it into the engine after. Now let's go back to the video. Before importing a new biped system, we need to rename the current existing root joint so that there won't be any problem or overriding existing joint system. We just need to rename one joint, and that would be the root joint of the AI mocap file. So select root and rename this to root_AI mocap. Okay, that will do. Now let's try to import the new biped system and let's see if there is not going to be any problem. Cool, the renaming worked. Both joint systems are working. Now let's take a look. No animation yet on the UE Manning, so let's start the process of transferring data to this mesh. Notice that this one has more joints compared to the previous one, but that won't be a problem, so we can ignore that. What we want to happen is to transfer the AI mocap animation into this mesh. So that's going to be easy. All we have to do is assign a source animation to our target mesh, and we can do that by going to character control. We need to create a character definition to prep our biped system and ensure that all attributes are transferred properly during the animation process. So let's just hide some stuff here so we are organized, and let's mimic the initial starting pose of the AI mocap biped. Let's re-angle the arms and make it the same as the AI mocap. Just do some minor tweaks before we begin, so that the movement would look more accurate. Checking. The scale of the biped won't be an issue here, so there's no problem. Let's begin assigning our first character definition to our AI mocap joints, and hide the other bipeded mesh. Make sure that you've selected the joint system and just hover your mouse over the character definition. A description will appear, so we know what joint needs to be assigned. We begin with a hip joint. Right click and then assign the selected joint. Now let's assign the rest accordingly. We're going to speed up the video to save time. So we can ignore the yellow warning sign. Regarding the finger joints, we're not going to work on this. Rather, it will be fixed and manually animated inside Unreal Engine. Our team encountered a problem before that we want to avoid right now. To explain further, here in this video, at first we tried assigning the finger joints and it created a lot of distortion to our mesh, especially on the animation stage, and that is what we're trying to avoid right now. Now that we're done with our first biped system, let's move to our second biped. We're going to create another character definition, but this time it's going to be for UE Man. We're only going to assign the major joints that we need, and the overlay joints that we see here on the shoulders, arms, and legs can be ignored. So we're going to do the same approach that we did with the previous biped, then select none, character definition, and let's speed up the video again. So now we have retargeted the joint of AI mocap and UE Mani. Now let's see if we have done the assigning properly. So let's just target mesh is UE Mani, source mesh is AI mocap, go to frame 1, then hit play. Alright, it's working. It's working just as it's intended to. Now all we have to do is import and check this inside Unreal Engine. But before that, we need to bake the animation to the UE Mani. Okay, that was quick. Now we can jump into Unreal Engine. Now that we have cleaned and prepared the file, we are going to test this inside Unreal Engine with our metahuman character. Okay, now we're using Unreal Engine 5.7 and we have imported our animation inside the scene. Let's test this out if it's working. The character that we created is working perfectly fine inside the engine. We could do a body swap from Quinn to Manny or the mannequin. For now, we're going to use Quinn since the animation we created can be used for a male or female character. Now let's try applying the animation to another character. And since we're working on metahuman, we're going to use a metahuman character for this project. So let's try retargeting this. So the target skeletal mesh will be the metahuman body. So let's look for the stage body mesh. Okay, so this is the body. So don't mind the headless body. We're just testing if the animation or movement would look okay. There's no any distortion whatsoever. Now let's try to add a name on it and export this after. So let's try mocap_transfer and let's create a new folder. Name this animation, then hit export. Now our animation folder contains the retargeted animation for the body. Our next step is to create a level sequence. Okay, so let's add a BP sage inside level sequence. And let's just adjust the timeline so the program will read the entire animation. And then select body and go to animation and add the mocap transfer animation. Oops. So make sure that you're on the 0, 0 position before adding any animation. Okay, select the body and hit the plus sign button. Go to animation and then select the animation that you want to apply. Now let's check hit save, and hit play. Now the metahuman character has adopted the animation from our motion capture reference. As you can see, there's a lot of tweaking that needs to be done here, but this can be used for pre-production stage. As of now, this character still needs a bit more love in the movements, especially on the hands and feet to be grounded on the floor. So we're going to fix the animation later on in this video, but glad to see that our character is working perfectly fine. So just a recap on everything we did. We shoot our video references. We transformed these videos into motion capture data, cleaned the mocap data in Maya and prepared it for Unreal Engine, tested the mocap data on our metahuman, and this. This is precisely where AI motion capture makes a difference. So thank you for watching and stay tuned. Oh, and don't forget to hit the like and subscribe button. This is helpful to support us in creating more educational content. Thank you.